Next, we want to look at the solar system. We want to continue looking at the solar system, and we're going to go from investigating the inner rocky planets to looking at the outer planets, which are also known as the gas giants. Now, the outer planets are gaseous, low-density worlds. They are all appreciably larger than the Earth, and they're more widely spaced out than the inner planets. In order of distance from the Sun, they are Jupiter, Saturn, Uranus, and Neptune. Now, let's talk about Jupiter. Jupiter is the first of the outer planets, and it's just beyond the orbit of Mars. It's more than 11 times the Earth's diameter. It's the giant of the solar system. It's the largest planet in the solar system. The composition is more liquid than gaseous or solid, and the atmospheric pressure is more than 1,000,000 times that of the Earth. So the pressure there is incredibly, incredibly high. Here you can see a picture of Jupiter. You can see a couple of the prominent features. One, there are these different bands. You can see Jupiter has got different bands, and these are different regions where the gas is separated by different temperatures. Now, the interesting thing about Jupiter is it has what's called a differential rotation. So what does that mean, differential rotation? It means that these different bands are actually rotating at different speeds. And so this one might be rotating really fast, and this one might be rotating slow, and that one actually could be rotating in the opposite direction. I don't have the arrows matched up with exactly how they are in reality, but the point is that some bands are going really fast, some bands are going slower, and some bands are actually going in the opposite direction, rotating backwards, as it were. So given that, how would you figure out what the day of how long is a day on Jupiter? Like we know on Earth a day is 24 hours. Well, the way we do it on Jupiter is we actually look at the magnetic field. The magnetic field of Jupiter rotates about once every 10 hours. And so we use that actually to define the day. So we say that a day on Jupiter is about 10 hours long. The other thing that you can see is that Jupiter has this region here which is called the Great Red Spot. And this is maybe not the best picture of it, but we'll see a better picture of it shortly. Okay, we can look a little bit more at Jupiter. Its atmosphere is 82% hydrogen, 17% helium, 1% methane, ammonia, and other things. There's no definite surface that occurs on the inner rocky planets. It does have a solid core of iron, nickel, and other minerals, but because of its thick atmospheric blanket, daytime and nighttime temperatures are about the same for equal altitudes above its quote-unquote surface. One of the things that we noted was the inner planets are all very close to the sun, and the outer planets are farther away. And this is sort of showing the relative scales of the different planet orbits. And so you can see the sun is, of course, at the center, and we've got Mercury and Venus and Earth and Mars are all revolving around the sun at a relatively close distance to the sun. Then you have the asteroid belt between Mars and Jupiter. And then each next planet, Saturn is out further, then Uranus is out further, Neptune is out further still. And beyond Neptune is a region called the Kuiper Belt. And you can see, I don't know if you can see this, it's spelled Kuiper. It's pronounced Kuiper. And there are all kinds of things in the Kuiper Belt, things from the size of grains of sand up to the size of small planets. And Pluto, we'll talk about Pluto. Pluto is actually one of these objects that's in the Kuiper Belt. So remember that when we talk about Pluto. Now, we talked about the band structure of Jupiter. Its other most prominent feature is the Great Red Spot. And here's a great picture. I love this picture because it shows the planet Earth compared to the Great Red Spot, and they're on the same size scale. So you could literally fit the planet Earth in the Great Red Spot and have room left over. What is the Great Red Spot? It's basically a giant hurricane. Now, the planet Jupiter has other giant hurricanes that form and dissipate, but this Great Red Spot has been there for as long as we have had telescopes able to see it. For literally, this hurricane has been going on for hundreds of years. So we don't really fully understand how that works, but it's pretty cool. And comparing it to the size of the Earth really brings home how big this massive hurricane, the Great Red Spot, is. Another thing that is prominent about Jupiter is it has a lot of moons. There are 63 moons that have now been found orbiting Jupiter, although most of them are very small. There are 4 very large moons that are called the Galilean moons. That's because they were first discovered by Galileo. And those are Io, Europa, Ganymede, which I already talked about. That's the largest of any moon in our solar system, and Callisto. The Galilean moons have similarities to the terrestrial planets. The largest of them is somewhat larger than the planet Mercury, and their density decreases as the density of Jupiter increases. Here's a picture of Jupiter. You can see the Great Red Spot, and also you can see the moon Io and the moon Europa. And here we see a shot of Jupiter's 4 largest moons. You can see their comparative sizes. Now, one of the things that was discovered not that long ago, but is one of the most startling discoveries about our solar system, is that Jupiter's moon, Europa, actually has a vast ocean of liquid water beneath its surface. And it's frozen on the surface. There's ice on the surface, but down far below is a vast ocean of liquid water. And how is that possible? Because Jupiter is so far from the sun. It's way outside that habitable zone we talked about earlier, the region of space where water can be liquid. Well, it turns out that as Europa orbits Jupiter, like the Earth's moon orbits the Earth, Europa orbits Jupiter, and as it gets closer and farther away, we know gravity, how strong the force of gravity is between 2 objects depends on how far away they are from one another. As the moon gets closer and farther away, the gravity from one side to the other is changing, and that causes the moon to flex, like it's being squeezed like a bellows. And that squeezing effect heats up the interior of the moon and provides enough heat to liquefy the ice and make it be liquid water. Now, this is an incredibly exciting discovery because, as we've already talked about, water is an essential ingredient for life. And so if you ask most astronomers where they think the most likely place to find life in our solar system outside of Earth, a lot of them will tell you in the oceans on Europa. And that is maybe many astronomers' dream mission. If we could somehow go to Europa and drill down through all that ice and sample the water there and see if there's life. Now, there could be some sort of complex life like fish or whatever. It'd probably be pretty alien, literally alien. But it might even be something like just bacteria. But even discovering bacteria would be exciting because we don't really know exactly how life forms. And we don't know how easy or hard it is. We know that life on Earth is very robust, but if life forms elsewhere, how hard is it for that to happen? And so, if we are able to find life in our own solar system outside of the Earth, that would suggest to us that life is actually pretty easy to get started, and maybe life is everywhere in the universe. Maybe it's all spread out through the universe. Now, if we don't find life in our solar system, it doesn't mean that life's not out there, but it does maybe make the odds a little bit lower. And so that's a very exciting thing, the idea that we might be able to find life that didn't come from the Earth somewhere in our own solar system besides the Earth. And Europa is one of the places where we think it might be most likely found. Now, the problem is that ice covering is really, really thick. It would be incredibly difficult to drill through that much ice on the Earth, much less doing it on another planet or on the moon of another planet so far away. The engineering and technical details of doing something like that are currently beyond our technology. But maybe someday, maybe even someday in our lifetimes, it will become possible. It's certainly an exciting thing to think about. Now, Saturn is the planet outside of Jupiter's orbit, the next planet outside, and it's remarkable for its gigantic ring system. A lot of people don't know this, but all the outer planets, Jupiter, Saturn, Uranus, and Neptune, they all have ring systems. It's just that Saturn's ring is so much bigger than everybody else's. It's like startlingly big. And so it's twice as far away from the Earth as Jupiter, so it's much farther out from the Sun as well. Its diameter is about 10 times the diameter of the Earth. That's excluding the rings. And it's also the lowest density of all the planets. If you had like a solar system-sized bathtub, Saturn would actually float in the water because it's less dense than water. Here we see a picture of Saturn that was taken by the Cassini probe that we sent there some years ago. And this is a true color image. A lot of times when you see pictures of Saturn, they've been digitally enhanced to provide more contrast, but this is actually what it would look like if you were there, which is kind of cool. Now, I love the picture I showed you a few slides ago of the great red spot of Jupiter, showing you just how enormous it is. Here's a similar picture comparing the size of the Earth to Saturn's rings. You can see that the ring system of Saturn is very, very large compared to the Earth. Now, here's what's crazy, though. It's really thin, too. It's about the size of like a skyscraper on Earth in terms of its thickness. It's not very thick at all, but it's really flat, and it's really, really, really big. And you can see the Earth here on a same size scale comparison. The other thing that's interesting about the rings is they're mainly made out of water ice. They're chunks of water ice. Some of them, again, the size of grains of sand, some of them the size of boulders, some of them bigger than that even, but altogether, the rings are just basically lots and lots of chunks of water ice. They're also rotating really, really fast. I often wondered what would happen if an asteroid would, crash into the rings. And what would happen is it'd be like throwing something into a blender. It would just be smashed because these things are moving so fast. Anything that crashes into the rings of Saturn is, likely to just be absolutely pulverized. Now, we talked about a few of the moons of Jupiter that were particularly interesting, especially Ganymede because it's the largest, and Europa because there might be life there. Another really interesting moon is the moon of Saturn called Titan. Now, Titan is interesting because it's the only moon in the solar system to have its own atmosphere. The atmosphere of Titan is so thick, you can't really see through it. So for a long time, we had no idea what we would find on the surface of Titan. When we actually went there, we landed a probe on the surface of Titan, and we found very Earth-like features. Look at these boulders here. Look how smooth they are. That suggests that there's erosion. And what actually we found was that there's liquid on the surface and rain. Now, it's not liquid water, it's liquid methane and liquid ethane, which are very volatile chemicals. On Earth, the temperature's hot, comparatively hotter, so that methane and ethane are gases. But the temperature on Titan is so cool that methane and ethane are in the liquid state there. And so there are these giant pools of these volatile chemical compounds. Now, we talked about how life requires water, at least life as we know it. And the reason for that is water is a really great solvent. A lot of different things will dissolve in water. And that allows chemical reactions and chemical processes that are necessary for life to occur. Some people think that those same kinds of reactions might be possible in liquid methane. Could there be some kind of life on Titan that is completely alien to what we know? Maybe. It's certainly something that is worth looking at, don't you think? So it's one of the things that people are actually investigating. We're trying to determine whether methane in the liquid state has the same kinds of properties that would enable life to form there or some other place that had similar conditions. And if so, maybe we need to send more probes there to take another look, because the probe we sent there wasn't specifically looking for that. The fact that there was liquid on the surface of Titan, that it actually rained there, rained liquid methane onto the surface, that was a complete surprise. In any case, you see here the other moons of Saturn. They're smaller than Titan, of course, and here they're compared to the Earth's moon. Titan is actually bigger than the Earth's moon. Now, another of Saturn's moons that's rather interesting is the moon Enceladus. Enceladus is really interesting because, like Europa, it has liquid water underneath its surface. And unlike Europa, it has geysers. You can see here images of the geysers. And so it's been suggested, rather than going to Europa and digging down through all that ice to get water samples to test if there might be some kind of bacteria or some other evidence for life there, we might have an easier time sending a probe to Enceladus and flying through one of the geysers and just scooping up some of that water that's being spewed out. That might be something worth doing. It would certainly be easier than going to Europa and getting a sample of the water there. So it's the kind of thing that people think about. It's kind of a cool idea. Another neat feature of Enceladus, you can see here these stripes here. This is actually called the tiger claw, and it looks, kind of like a tiger has clawed through and scratched the surface of the planet. The surface of the moon. And the interesting thing is that these stripes are actually at a hotter temperature than the surrounding areas. Now, of course, they're all crazy cold, but the stripe parts of the tiger claw are considerably warmer than the flatter parts. Now, the next outer planet is Uranus. Now, Uranus is much smaller than Jupiter and Saturn, but it's, of course, much larger than the Earth. It's still considered a gas giant. It's very, very cold there. One of the interesting things about Uranus, most of the planets in the solar system rotate like the Earth. So here's the sun here, and here's the Earth, not to scale. And the Earth rotates about an axis that's tilted, but it's pretty close to being upright. It's just tilted over a little bit. The axis that Uranus rotates about is like that. And so this would be the side of Uranus pointing towards the sun, say, and that side, the bottom of the planet is always facing the sun, and the top of the planet's always facing away from the sun, which is kind of crazy. It may be that sometime in Uranus's distant past, it had a collision with the planet that sort of knocked it over onto its side, but it's the only planet in the solar system that behaves that way, so it's kind of interesting in that regard. Now, Neptune and Uranus are actually very similar to each other. Neptune is, of course, much further out, and it has a very highly elongated elliptical path around the sun. Most of the planets they all orbit in elliptical paths, but most of them are pretty close to circular orbits. But Neptune has a very flattened out elliptical path. Now, the last of the quote-unquote planets is Pluto. Now, Pluto used to be a planet, but in 2006 it got demoted, and it's now called a dwarf planet. Now, why was Pluto demoted? As I mentioned previously, a lot of people were really upset by this. And it has to do with the fact that Pluto is one of those Kuiper Belt objects. Remember the Kuiper Belt's that region of rocks outside the solar system. And Pluto is one of the planet-sized rocks floating around in the Kuiper Belt. Now, a very small planet to be sure, but definitely planet-sized. But very, very tiny. I mean, Mercury is the smallest planet in our solar system now, and Mercury is significantly larger than Pluto. So Pluto is very tiny. But the main reason that Pluto was demoted was because in the Kuiper Belt, there are lots of other things that we would have to call planets if Pluto was a planet. And so rather than the solar system suddenly having many, many planets, they realized they never really defined what a planet was. It was kind of those things, oh, a planet, I know it when I see it. But astronomers had never really defined what a planet was. And in 2006, they got together in this big conference, and they basically decided that there were certain requirements for a planet, for something to be a planet. It had to orbit the sun. It had to be spherical shape. That is, it had to have enough mass that its gravity would attract it and compact it into a spherical shape. And then the last requirement was that it had to clear its orbit. And that's the one that Jupiter fails on, because Jupiter orbits out into the Kuiper Belt. And so its gravity is not strong enough to sweep away all the debris around its path. And so that's what we mean when we say it doesn't clear its orbit. And so Pluto is no longer considered a planet. It's now what we call a dwarf planet. Now, I mentioned a lot of people got really, really upset by this, but that was actually the best thing to happen to Pluto from a scientific perspective. Because Pluto overnight went from being the least interesting planet in the solar system to being the most interesting dwarf planet. And there are other dwarf planets in our solar system, by the way. But Pluto is the biggest, and it's the most interesting. For a long time, we didn't really have any idea what Pluto looked like. It's just so far away. Even our best telescopes couldn't really get a good image of it. And so a few years ago, we actually sent a space probe to fly by and take pictures of it. And this is one of those pictures. And one of the most startling features is you can see this flat region where it looks kind of like a heart. And so you may be one of the people that was upset by Pluto being demoted, or maybe you know somebody like that. But don't feel too bad, because Pluto is doing okay. And Pluto hearts you, and I certainly heart Pluto, and I hope you do as well. Anyway, those are the planets of the outer solar system, including the dwarf planet Pluto. And we're going to continue talking about a few other things in our next lecture to wrap up this chapter.